Hello students. In today's session we are going to move further of science chapter number 3, that is atoms and molecules. So in today's session we are going to study about radicals. Radicals are groups of atoms that bear a charge. They are also called as polyatomic ions. So radicals, they are the groups of atoms that bears some charge. So if we take example of hydrogen, so hydrogen is H plus, that means it has positive charge, plus charge, and the valency or we can say the change is 1 because here no numbers are there. Another example if I take is Cu2 plus. Cu2 plus means it has the change of 2 and charge is positive. If I take SO4 minus, so that means it has negative charge, right? So these are known as radicals, that is they have some charge on them. We can also call them as polyatomic ions because they have so many they have more number of atoms. The number of atoms is more than 2. So here chemical formula is there. Chemical formula is a symbolic representation of a compound. It is a symbolic representation. How that we will see, and to write a chemical formula we should learn valencies and radicals first. So first you should know the radicals and you should know the valencies, then only you will be able to write a chemical formula. So there are some rules for writing a chemical formula. Before we move further, let's discuss about these rules. The valencies on or charges on the ion must balance. If you want to write a chemical formula, the valencies and the charges, the ion that consists of valencies and charges, that should be balanced. Second, when a compound consists of a metal and a non-metal, the name or symbol of the metal is written first, whether the compound is metal or non-metal. So when a compound that consists of both metals and non-metals, at that time the symbol of metal is always written first. For example, if I take off calcium oxide, so here calcium is a metal and oxygen is a non-metal, so we will write down calcium first, that is Ca, and oxide, that is oxygen, behind Ca and then O. Another thing if I tell is sodium chloride, another example. So sodium is a metal, chlorine is a non-metal. So sodium we will write down first, Na, and chloride, that is Cl. Then iron sulfide. Iron is a metal, sulfur is a non-metal. So iron, that is Fe, sulfide, that is sulfur S. Copper oxide. Copper is a metal, oxygen is again a non-metal. So Cu, copper, and oxide O. So here oxygen, chlorine, sulfur, they all are non-metals. So they are always written on the right, whereas calcium, sodium, iron and copper are metals. So they are written on the left. You just remember one thing, when metal and non-metal both are present in the compound, metal is always written first. Third thing is, in compounds formed with polyatomic ions, compounds which are formed with polyatomic ions, the number of ions present in the compound is indicated by enclosing the formula of ion in a bracket and writing the number of ions outside the bracket. If that compound consists of polyatomic ions, so how will we write the formula of that ion? We will write down the formula of ion in the bracket. Formula of that ion we will write in the bracket, and the number of ions we will write down outside the bracket. For example, if I take off magnesium hydroxide, magnesium hydroxide can be written as MgOH twice. This way it is written, magnesium hydroxide. So that means the formula of iron is written in the bracket and the number of ions is written outside. That's why we always term it as MgOH twice, not MgOH2. Okay. And in case the number of polyatomic ion is 1, then the bracket is not required. If the polyatomic ion is only 1, for example, sodium hydroxide. Sodium hydroxide we generally write as NaOH, right? So here the bracket is not required. These are the rules which we have to keep in our mind while writing a chemical formula. So here the name of radicals are given plus their formulas are given. You have to remember the name of the radicals, or you have to learn the valencies also. For example, hydrogen, the formula will be H plus. So change is 1. Sodium Na plus, 1 change. Ammonium NH4 plus, 4 is always written in the bottom. So change is 1. Chloride, chlorine is 1, Cl minus. Cupric, here the symbol is Cu2 plus, so the change is 2. Ferrous, Fe2 plus, so it is 2. Aluminium, Al3, here it will be 3, so 3 plus. 3. Antimony Sb3 plus, changes 3. Boron B3 plus, changes 3. Ferric Fe3 plus, changes 3. Phosphate PO4 3 minus, changes 3. See, always remember, for ferrous it will be Fe2 plus, ferric it will be Fe3 plus. Okay, now let's learn the formula of simple compounds. How to write the formula of simple compounds. Now, the simplest compounds which are made up of two different elements are called binary compounds. Bi means two, means the compounds that are made up of two different elements, we call them as binary compounds. And you can see these to write, you can use these. You have to see the valencies of ions on the table given in the table given on page number, it's table 3.6. it is given on page number 37 of your textbook. While writing the chemical formula for compounds, we write the constituent elements and their valencies, and then we must cross over the valencies of the combining atoms. Okay, let's see with the help of an example. Suppose we want to write down the formula of hydrogen chloride, that is HCl. Okay, we want to write down. So the symbol is H and Cl. Okay, so both of them consist of valency 1, right? 1 and 1. Now we will cross over the valencies. This we will cross with this and this we will cross with this. Both are having valency 1 1. So the formula will be HCl. Another, if we want to see hydrogen sulfide. Hydrogen sulfide. So the compound symbol will be H and S, right? So the valency for hydrogen is 1, for sulfide is 2. Now we will cross over. This we will combine with this and this we will combine with this. So this 2 will go with H and 1 will go with S. So the formula will be H2S, hydrogen sulfide. Okay. Another formula if you want to take, carbon tetrachloride. Okay, carbon tetrachloride. So the symbols will be H2S. If I take the symbols are carbon tetrachloride, C and Cl. Now tetrachloride, for carbon the valency is 4, right? And for the valency of chlorine is 1, right? Now we will crossing over. So carbon, 1 will go with carbon and 4 will go with chlorine. So CCl4, 1 we never write. Okay, CCl4. This is the formula of carbon tetrachloride. You have to learn the valencies. I am telling you, you have to learn the valencies. Another, if we take magnesium chloride, okay, magnesium is Mg, chloride is Cl. Magnesium, the valency is 2, chlorine is 1. Sorry, here we have to consider the charge. Valency or charge you can take. So the charge, now we will cross over. So it will be 2 with go with chlorine and 1 will go with magnesium. So MgCl 2 MgCl 2 magnesium chloride. This way you have to form the formula of compounds. Okay. Now we will go with the concept of molecular mass and formula mass. Molecular mass is also known as formula mass. There is no difference in that. Okay. So let's study. Molecular mass is the sum of atomic masses of all the atoms. It is the sum of atomic masses of all the atoms in a molecule of the substance. So it is therefore the relative mass of a molecule which is expressed in atomic mass units. For example, if I take the relative atomic mass, if I want to calculate of water is H2O, right? So hydrogen is 1. The atomic mass of hydrogen is 1. Here it is 2. So 1 into 2 plus. It is the sum of all the atomic masses. Okay, sum. So plus oxygen is 16. Atomic mass of oxygen is 16. So 2 into 1 will be 2. 2 plus 16 will be 18. So the relative atomic molecular mass of water is 18. I hope you are clear. Another example, if I take, is HNO3. Okay, if we want to take HNO3, so how will we calculate it? HNO3. Hydrogen, the atomic mass is 1, plus nitrogen, the atomic mass of nitrogen is 14, plus 3 into atomic mass of oxygen is 16, right? So here 1 plus 14 plus 3 into 16 is 48. So this goes on to total 63. The unit of atomic mass is U. So you have to write down U after calculating the molecular mass. The unit of molecular mass is U. This is only the molecular mass and formula mass. Both are same. Molecular mass is formula mass. So this way you can calculate the molecular mass. It is easy. It is the sum of all the atomic numbers of the atoms in the molecule, right? So this will be your homework. You have to calculate the molecular mass of zinc sulfate, ammonium chloride, and for calcium bicarbonate and carbon dioxide. This will be your homework. You have to do it by your own. Another thing which we are going to study is mass percentage. Mass percentage of the elements in compound. So this can be calculated as how to calculate the mass percentage. Mass percentage can be done. The formula for mass percentage is atomic mass of one atom. Atomic mass of one atom upon the molecular mass of the substance. Suppose if any substance is given, any molecule substance is given, as if suppose CaCl2. CaCl2 is given, that is calcium chloride. So the atomic mass of calcium plus the molecular mass of calcium chloride. This gives us the mass percentage. Okay, I hope you are clear with the concept. This is just for the this is just a brief introduction about the mass percentage. This you will study in detail about in your higher classes. It was just this is molecular mass of CaCl2. It's just an example, just a brief introduction, short intro. So with this we complete our chapter number 3. I hope that you are clear with all the concepts of the chapter. If you have any doubts, you can ask me. And in the next session, you will be provided with the exercise. The exercise, textual exercise, you have to write it down in your notebook. And the additional questions will also be given, which will be just for your reference, for your information. You don't have to note it down in your classwork notebook. It will be just for your reference. Okay, with this, we complete the chapter and today's session. Thank you and have a great